streamer, like stream starting soon.
Yeah. Exactly.
I don't think I can bring myself to do the Twitch thing.
Cool. Looks like we have a good number of folks. And then this is being recorded as well. So I think we can go ahead and get started. So my name is John. I'm a EM on the Gitaly team. And yeah, we wanted to do a series of talks. I guess we're calling it training sessions. Originally, the audience was support folks because, yeah, Gitaly is a pretty complex topic and comes up a lot. Issues happen with customers or even on GitLab.com. And so we just wanted to provide a series of talks to um, kind of dive into different aspects of the Gitaly code base, I guess. Well, not just the code base, just how it works and how it works with other parts of GitLab, just so folks can get more familiar. And so, yeah, today, Will Chandler, he's a senior backend engineer on the Gitaly team. He has a support background as well, actually. So he's going to give our first session on like an overview of Gitaly architecture. So take it away, Will.
Thanks, Sean. Let me just make sure we're recording. It is okay. We're recording it. Cool. All right. Yeah. So this is just supposed to be kind of a high-level overview of Gitaly from kind of the admin perspective mostly, and how the components fit together. All right. Can you see my browser?
Yes.
Okay. Cool.
Sorry, Will, I
Yes.
forgot to say one thing.
Sure.
So we're gonna have Q&A at the end. So, oh, whoops, I just sent the wrong link. Okay, I'm gonna send over the agenda doc in the Zoom chat. So feel free to put down any questions under the question section, and then we'll have about 20 minutes for to answer those questions. So sorry about that. Go ahead, Will.
Oh, no worries. Okay. Yeah. So basically, my goal is to kind of like walk through what does this diagram mean in a little more detail and give you some more ideas on what Gitaly is doing under the hood. So Gitaly is a gRPC server that handles any Git operation you're doing within GitLab. So anytime you're looking at a file or looking at branches or anything that's touching the repository, that's going through Gitaly. In the past, we had a sidecar called Gitaly Ruby that is gone as of 16.0. I don't remember. Tone did that work. Thanks, Tone. And then as of like 16.4, there is also another binary we're launching called Git2Go, which used libgit2, but that has now been fully replaced with just Git. So any Git operation you're doing, we are just forking a Git process, basically standard Git. I think we occasionally will use our own patches on our Git version, but typically we just try to stay with the upstream version of Git. And so we're just forking that and reading from standard out typically to get the whatever the details are. Okay, so there are kind of three main clients that Gitaly serves. So there's Rails itself, so like a Puma process. So anytime you're actually like looking at a project that's Puma sending RPCs, if you're familiar with the performance bar, which you can get with hitting P and B on your keyboard, you can just click here and see all the RPCs we're sending. So find license, and you can see all the parameters we're sending. So typically anything that Rails is sending is going to be small, like, hey, show me what files exist by this name, or what are the references that exist and so forth. And so those are all going to be over gRPC, and they may or may not be streaming gRPC responses. Sometimes they're unary or like a single response. Sometimes they stream back depending on the size. But that's Puma. And then next would be Workhorse. So Workhorse is going to be a longer lived connection because Workhorse it's pretty unusual to restart it. So any HTTP Git operation, which on GitLab.com will be 95% of CI, or in any environment really that's using GitLab CI, it's going to be HTTP, right? So usually you'll see most of your clone or fetch traffic come out over Workhorse. And so when we're doing any kind of clone or fetch, we use what's called the sideband. So originally we were sending the the pack file details over gRPC, which involved getting the output from Git, encoding into your gRPC buffer, sending it over to Workhorse, and then de-encoding it and writing it up to the client. And that was inefficient. So it was a year or 2 years ago now, scalability team added what's called the sideband connection. So we multiplex the gRPC connection to create a very simple pipe on there that will just send the pack information in the clear, so we don't have to encode it. So that saves a lot of CPU time. So that's why you'll see like post SSH upload pack or post upload pack with sideband. That's what that with sideband is referring to, is this multiplex connection that we have running. Yeah, thank you. Sideband is Git itself. Side channel is the, thank you, Tom. Right. And so like I said, any kind of Git client operation, so like a CI runner cloning or fetching, or someone just on their own terminal doing a fetch, will use Workhorse. And then the final connection or client is shell. So that'll be for incoming SSH requests. On GitLab.com, we're using GitLab SSHD. So that is a stable process. And so that will have an existing connection out to Gitaly. And so we can kind of reuse that connection. On self-managed instances, that's off by default. So when a new connection comes in, we're going to the standard OpenSSH SSD is going to fork a GitLab shell process, which will then establish a new connection. So you'll see a lot more connection churn there. Things will be much more ephemeral when it comes to that. But it's the same deal as Workhorse, where it's just over SSH. It'll be any Git client operation. So that is more likely to be humans in most environments. Some self-managed customers use SSH for their CI, so it's not always, but it depends. So this is the closest thing we have to a diagram, which is this page here. This does not mention shell versus, well, this is in the Gitaly docs. There is also like the larger GitLab.com architecture somewhere in the docs. I don't know if someone knows where that is offhand. I don't have the link handy, but that's pretty enormous. But you can pick out all the stuff I'm talking about there too, if you know what you're looking for. It's just there's a lot more stuff going on. Okay. And then occasionally you also have Gitaly nodes talk to each other. For example, if I am working a project that's not using an object pool, I might need to go from one Gitaly server to another to fetch the details of that project and then clone it over to my own Gitaly server. And I'm not actually sure if this like loopback connection to itself really happens these days. That used to be for Gitaly Ruby, where we would like connect over like to the host address that Rails knew it by. But I don't think offhand that we still do that. So this might be a little out of date, this section here at the bottom. Okay, all right. So those are the 3 clients that we have. What was I going to show you? Oh yeah, one thing that's kind of interesting to see. So here is a standalone Gitaly node. Actually, let's go here. So if we look at the storage section of the config, if we look at, which is corresponds with the storage section in the Gitaly configuration. So you can see here, there's only one storage name listed here. So if I wanted to fork, so let's say I had a repository on Gitaly 1 here, and I wanted to clone it over to Gitaly shard, to fork it because it's a private project and we can't use object pools. Then what you'd have to do is you have to create a connection. But Gitaly itself is not aware of any other Gitaly nodes. So like on .com, actually, if you look at the configs, you'll see that like all the Gitaly storages are listed in the config, but it's only there for ease of configuration. In reality, it's only using whatever storage that node is actually configured for. So that's slightly confusing. But basically, how does this Gitaly node know to talk to this one when it doesn't have in the config? The way it works is in the Rails node. Actually, let's use Vim. Rails will bundle in the addresses it's aware of in the gRPC headers, so that we can fetch, so that it tells the Gitaly clients, here's where you need to go to the other Gitaly node. Let me show that in action real quick. Right, we moved. I don't know why they got rid of the wrench. Oh, that's fine. Right, repository. What do I have as the primary storage right now? Okay, so my cluster is this, where everything's going. So let's fork this. We also enable no, that's already on. Turn that off. So this Go debug HTTP2 debug is enabling extremely verbose logging on Gitaly, which you never want to do in a production environment. Yeah, right. But for our purposes, it's handy. So you can see if it's like writing out each header that's receiving on a request. All right, so let's do that. And so now if I fork, okay, here we go. Yeah, so you can see in the we get this Gitaly servers field, and then you get the space64 encoded string. And then if you span that, you can see that it's a JSON blob that says, hey, here's this Gitaly server shard, which you can see here in the Rails config. And then here's the address, here's its token so that you can authenticate yourself. So that is how Gitaly servers know how to communicate with each other. There's never any config on the Gitaly node itself, as of today at least, to talk between nodes. A lot of this is subject to change. Like we're planning to completely overhaul how Gitaly cluster works, and that's going to add some client-side routing, which hasn't been implemented yet. And so this may be subject to change, but right now this is how it works.
Hey, Will, could you
yeah.
explain real quick why during a forking process a Gitaly would need to know about another Gitaly node?
Yeah, so it depends. So if you have a public project or an internal project, Gitaly will create what's known as an object pool, which is kind of like a separate Git repository, which will be prefixed with an @pools path on disk, and that will have all the objects in common between the forks. So that way we do duplicate most of the repository, usually almost all of it, and we can save a lot of space. So if you have a project like GitLab, which has hundreds or thousands of forks, I don't remember that off the top of my head. We don't have 500 copies of the repository. We have 95% of one copy, and then 5% scattered around across the other ones where they differ. So that lets us be much more space efficient. However, if it's a private project, we always create a new full repository. And so that's what I did in this case. And so in that case, if you have, let me go back to the admin page. Repository storage. So this page here in the admin under repository lets you set a relative weight for where your new repositories are created. So right now I have all of my repositories being created in my default Gitaly cluster, and none of them go to shard. And I can change that to whatever weighting I wanted. If I had certain nodes that I wanted to fill up and other ones to not be touched, then I would adjust that value. Anyway, so in this case, because I'm creating all new repositories in default, and the existing copy of the repository wasn't shard, the default Gitaly nodes, which are in a Gitaly cluster, will have to reach out to shard and say, hey, give me this repository. So it'll do a fetch and get all the objects and create its own bearer copy of the repository. I'm going to show you what it looks like on disk real quick. So by default, this is the directory that Gitly or Anonymous instance will put the repositories in. You'll see this .gitly metadata file, which is historically been used to identify whether or not we've been using NFS. So basically, the way it would work is Rails would validate what this file looks like on its end, and then the Gitly server would also say like what the UID it has. If they match, then we say, oh, okay, this must be NFS, and previously we'd use rugged, which is replicate 2 bindings for Ruby.
Hey, sorry, Will. I don't know if
Yeah.
other folks are experiencing this, but I think it's getting cut off at the bottom for me. Could you just type thing clear real quick?
Yeah.
Thanks.
Sure. Anyway, so I can't remember off the top of my head if we've removed rugged entirely or not. I think we've disabled it, right, John?
I think yeah. Well, I think you can well no, you can still use it if you really wanted to through feature flags, but for all intents and purposes, it's not being used by the application.
Don't use it.
Rugged will be removed in 16.5. Oh, that's the current plan.
Great. Okay. Well, we won't talk about it too much then. All right. And you have this .gitly directory, or plus Gitly, excuse me. And this is kind of Gitly's scratch directory where when we're deleting a repository, for example, we will rename it as a repository name -deleted in this directory, so we can atomically move it out of place, and then from there we can delete it. And we create caches for the reps that we're serving. That's another thing that's in there. It's really implementation detail. And then this @cluster directory will have the actual repositories itself. And if I had any pool repositories, there'd be a pools directory here too. And this is the new format. That's interesting. So you can see we have some bare repositories in here with commit graphs, backfile, reverse index, bitmaps, all the different housekeeping things that help Git be efficient. And this is a file that Gitly creates to say, hey, when's the last time we did a full repack, so we can keep track of that as well. If I go here, I think I see, yeah. Okay, let's go here. There we go. Yeah, sorry. Okay. So just to explain a little bit more. So this host here, training Gitaly 2, is within the Gitaly cluster. And so Praefect will use this @cluster format for its paths. Well, this is a sharded Gitaly, so standalone Gitaly, which is what almost all of our Gitaly nodes at .com are, and what you'd see in a typical small self-managed instance as well. Right. And so here we use the @hash format for the path. And so this is the path that you'll see internally in Rails as well. So if we go to projects, and so like if I look here, I can say, okay, this is the path that Rails has for the project. And this matches up with what we have on the shard. However, if you look at a project that's in the cluster, it'll show up as hashed, but there is no path at hash 6b86 on the disk file system here. So what we have to do let's go into the Praefect, which I haven't mentioned. I'll get back to that in a second. Database to map that between them. So actually, before I go any further, let me actually talk about what is Gitly cluster. So Gitly cluster is a way of having multiple copies of a repository that are kept in sync with each other without it's exposing only a single instance to Rails. So it's a way of getting redundancy, which is not something that we have with the sharded Gitly. There's no way to replicate a repository to multiple different shards in the current setup. So what that does is typically you'll have a load balancer and that'll be the address that you give to Rails. Let me show you here. So like, for example, here, this could be my load balancer. In actual fact, I only have a single Praefect node. In production, you typically have 3, maybe more. One failure mode we've seen somewhat often with self-managed customers is if you have more Gitaly nodes behind Praefect than you have Praefect, they can send so much traffic that it overwhelms the network connection or network bandwidth that is available to the Praefect node, and that will cause silent slowdowns. It used to cause memory bloat on Praefect, but that's been fixed as of like 15.5 or something like that. Anyway, so Praefect nodes, they're stateless. They have a Postgres behind them, and that tracks all the repositories and the state of all the repositories, and which repository is going to which node. So if we look at the repositories table, let me make that bigger. So right now we've got 4 repositories, 2 of them being wikis, 2 of them being actual projects. And so you can see this is the path that Rails knows. So if we go back here, it's @#6b86, etc. But if you look here, it actually maps to @cluster repositories D4732. And you can see Gitaly 1 is the primary node for that, which would make Gitaly 2 be one of the secondaries. I only have 2 Gitaly nodes in this cluster. Typically you'd have 3. 2 is fine if a customer only wants 2. There's no need for quorum or anything like that. And this generation counter is saying like how many changes have happened. So this is how we keep track of which node is in what state. So if the generation counter is the same, so if we look at storage repositories, so you can see here they both have the same generation. So in this case, a read request for this repository could be read to either Gitaly 1 or Gitaly 2 because they're both at the same generation. So this lets us, on active repositories in particular, distribute reads among multiple nodes and decrease the load on the primary. Any write will always go to the primary. And one issue that some customers are seeing right now, in general, is that if a write cannot be simultaneously proxied to the secondary, and they don't agree on it for whatever reason, so like the secondary fails for an update for whatever reason, then the secondary falls behind and it has to replicate to basically do a fetch from the primary. If it's a very large repository, that fetch might take 30 seconds, and in which case, and if changes are coming in faster than that, the secondary might not catch up to the primary for hours. And so in that case, we wouldn't be able to distribute reads. We'd all writes or all reads would have to go to the primary along with any writes. And so you're losing most of the benefit other than, having redundancy in terms of, the primary hard drive failing. In that scenario, you can't spread the load. So that's a failure mode that we see somewhat often. It's been improved. I think pretty much all RPs at this point won't do that. For a while there were some that would always trigger a replication, and that that just decreases the efficiency. Okay, so this is kind of internally how Praefect nodes are tracking, like how can I route a request? So basically the request comes to load balancer. Load balancer chooses any of the stateless Praefect nodes. Praefect will check the database, say, okay, I can send this request for repository 6b86 to either Gitaly 1 or Gitaly 2 because the generation is 3. It'll route it, and then it'll proxy the gRPC request down to Gitaly, one of the Gitaly nodes, and then Gitaly will do its thing, send it back out to Praefect, which proxy it out to the load balancer, will send it back to the client, and so on. So there are a lot of steps there. So how does Gitaly actually get data? So I'll show that real quick. So I'll just strace it. Actually, no, let's do this in the shard. That makes more sense. And hopefully everything I'm saying makes sense. Okay. start that. And let's go to shard. So just building up this page will have triggered some. Yeah, all right. All right. Let's actually pipe that to head. It's kind of hard to read, isn't it? Sorry. Anyway, so let me walk through what's happening here. So the Rails sent a request to pull up a project. So it's going to send a few RPCs. So like if we look here, you can see it sent search files by name. In this case, we are looking for in the Gitaly, the wiki itself. And then it's looking for markdown files in the wiki repository. You can see the regex that we're sending. And then in addition, we're also to, this is also to the wiki. That's interesting. I'm surprised we're doing the wiki, but that's fine. Has local branches. So it's saying, hey, what branches do you have to this repository? And so here you can see this is the file that's actually being forked. So it's not opt embedded bin opt GitLab embedded bin git. Gitaly, when it launches, will extract its own git own copy of the git binary. So let's actually just expand that directory. So here you can see everything that's there. So you've got git to go, which, as I said, should be gone with the next release. And then you have Gitaly GPG. We use that to sign and validate signatures on commits. Hooks is used for, well, it's used for the pack objects cache is kind of one of the primary things, which I'll get into in a little bit. LFS smudge is used for handling LFS objects, and that's kind of a long-lived process that we use to make it more efficient. And then Gitaly SSH is used to connect internally between Gitaly nodes. And then we also have hooks and socket directory in there as well. Okay, and so, sorry, something just started printing. It's confusing. All right, so then we got this git directory saying, hey, you want git operate in this directory here. And we always say, don't run git GC automatically, which by default, Git will run GC on some operations just as like a standard housekeeping, but Gitaly controls housekeeping, so we don't want that. We were saying treat control F for whatever you're receiving, or CRLF, the line ending. Don't use replace refs, which has been a security issue. These are the objects that we fsync. So objects, metadata, references are fsynced by Git whenever we make a change there, and then fsync is fsync. And this, I believe, has to do with reducing contention on the pax refs file. Okay. And so then here's the actual command we're running, which is get cat files. This is saying, give me a blob. And then we're running Z, which will give it like null byte terminated. And then we're saying batch command, which is saying we're going to send you a number of commands over time. So let's see if we have any cat file processes right now. We don't. So what Gitaly does for these Ruby or Rails operations that are often making lots of little requests. So like I want to look at this file, I want to look at that file. Within the context of a given Rails request, so I think it works out to a single correlation ID, we will fork a cat file process and then keep that around so that we're not, for each file that we're trying to view, we're not forking a new cat file process. So this lets us be a little more efficient, fork fewer processes. So when you look at a production server, you'll probably see a whole lot of cat file processes around. Those are mostly just there cached, waiting to see if any more requests come in for that given request, for that given overall like web request that's coming in. So that's why they're there. And then the other thing you'll see a lot will probably be upload pack or pack objects related to clones. Those will be long-lived typically for a larger clone, so they'll be around more. Anything else I want to talk about? Well, let me pause right here first. Anything that Any questions that are like immediately relevant that anyone wants to ask?
I have a question. Just
Yeah.
what's the logic behind creating its own fork of the Git executable? Is there any reason for it, or?
Let's Gitaly have more control over what Git process or what Git binary we're running. I don't remember the reason that it was difficult to keep it in sync with Omnibus. But this way, we didn't have to rely on Omnibus updating what Git it bundled. We could very, control exactly what we were executing. And clients or admins can still override the Git binary. So I don't believe we have to use this. That's not something we recommend, but it is something that you may encounter in the wild if you're dealing with a self-managed customer.
Yeah, another reason is sometimes if there's like a security fix or some high priority fix, we will build a Git binary with some of our own changes. Usually we ship the standard Git binary that's released, but sometimes we'll ship with some of our own changes. So yeah, if self-managed customers use their own Git binary, it might break because it doesn't have the features that Gitaly needs.
But we don't ship the security patches to our customers before they're released.
Yeah, that's right.
Thanks.
Yeah, well, one other thing I can talk about within the context of Gitaly cluster is failing over between primaries. So if I go back up here, so right now we have for this repository Gitaly 1, its primary is Gitaly 1. So that is this Gitaly. No, that's not that one. Let's go back. So that is it this one? Yeah, this one. Okay. So if I go to Gitaly 1, just stop Gitaly. And then I send a request to view the project. We should fail over at this point just to Gitaly 2. No, that's interesting. I wonder if I need to go in and actually pull the file. Okay. Yeah. What am I doing wrong? Can't. Well, I wonder if I need to make a push because it might just be routing the reads there. Let me actually try modifying something. So just create a new file. Okay, I just didn't test that. I need to update. This is a config problem. It's not writing out to the right address for the internal API. All right. Well, this might not work. Should have tested this beforehand. Oh well. No, actually, I was just reading it wrong. It did update. Okay.
Probably just took a second longer.
Yeah.
Than get it.
Maybe it already changed. I didn't even look right. That's probably it. Anyway, so you can see now for this repository only, we have now updated the primary to be Gitaly 2. So the way failover works is when a request comes in that the primary needs to handle and the primary is not available, then we will update the primary to be one of the other in-sync nodes within the Gitaly cluster. If there are none, then the repository will become unavailable until a up-to-date node returns. But we only do that for repositories that come in, that have requests come in. So you'll note that this other repository has not updated, even though Gitaly 1 is offline. Originally, we did update all of the repositories, and that caused a lot of work in Postgres, and you didn't have to do it that way, right? So now it lazily updates the primary as needed. So that's one thing that might be relevant. Okay. Yeah, and then I'll just quickly mention, you may see deadline exceeded errors in the logs. That means that some operation that Rails typically, it's almost always going to Rails or Sidekick, sent took longer for Gitaly to serve than the timeout configured in the admin area. So if we go back again, leave page. There, just go admin. Preferences, Gitaly timeouts. So whatever these values are set, and whatever the operation is, the timeout will depend on the operation that you're doing. But if it takes, particularly if it's a large repository and it takes longer than this, then you'll see a deadline exceeded. The other area you'll see a lot is canceled, context canceled. That means typically that there's somewhere between Gitaly and the client, the connection went away. Maybe the client closed their Git process. Maybe the load balancer went out. It could have been anywhere along that chain. If the connection is lost, then you'll see that connection or context canceled error message within Gitaly. So basically, it just means that the client went away for some reason. We don't really know why. You should look upstream to try and figure out why that happened. Okay, yeah, I think that covers everything I wanted to go over. Let me stop sharing for a quick second, and I'll pull up the doc.
Thanks, Will. So, yeah, I know that was pretty technical. So if you have any questions, or if you want Will to go over maybe one of the parts that he already went over, again, maybe yeah. So, please put those in the questions, and we'll go over them one by one.
Okay. Oh, Gerardo asked why we use our own Git executable, which I think we covered. Manual. Oh, so the pooling feature. Yeah. Karthik has answered that. So we're using a built-in Git feature called alternates. So basically, you can say, here's a repository on disk, and then you have an alternates file within it. It'll say, okay, and I'll also go to this other directory and use that to get additional objects from it. So we're saying, all of you pool repository, all you projects that are using this pool repository, we add that alternate of the pool to them, and so then Git itself just knows, okay, I need to go to this other directory, which is just a relative path to fetch the objects. So there's a limitation, which is that because it's a relative path, it has to be on the same node. Like we can't tell Git like use an HTTP request or something to go do it. So that limits any fork cluster to a single Gitaly node. Within a Gitaly cluster, in theory, you still have the forks spread out or replicated amongst all the nodes. That was broken for a long time. I think Justin has gotten that basically fixed at this point, or close to it. So it should start working soon if it doesn't work now. For a while, we weren't keeping those in sync accurately. Does that answer your question, Manuel? Maybe he left. Okay. Steve asks, is there a specific reason why we put things in the cluster directory? As why are we adding extra overhead of translating the path through Praefect? So I think the main answer there is that we wanted to have a permanent home for a given repository, but Rails was still asking us to move repositories around on disk, particularly in the context of geo. So you'd have like a new repository be created at geo temporary, and then once the geo fetch had completed, then it would get moved into place. So the reason that we have the @hash name in Gitaly or on Gitaly shards is the same logic. Originally, the path on disk was the repository name, so like including the project. So it'd be like fire up GitLab, Git repositories, GitLab-org, GitLab would have been the path for GitLab. But whenever you had someone rename their project or rename their organization, we ended up doing a ton of work on disk to just rename all these directories, and it was expensive and error prone. So that's why we created the @hashed format. And so then this @cluster thing is doing the same thing, just at another level of abstraction down. So this way, Gitaly cluster knows that a repository is always at this path, even if Rails thinks that it's moved somewhere else. So that's why we added that. It does
Okay,
add another
so
layer
the-
of complication.
The add cluster is always the same, no matter which Gitaly shard we talk to. Like
Correct.
not talk to, but it lives on. Okay.
Yeah. So if you look at oops. Yeah, sorry, that was actually over here. So if you look at the path, so it's actually the hash of the ID, but instead of taking the full hash here, like we do with @hashed, we just put the actual number here. So this is the full hash of number 1. This is also #1. Just use 1 at the end. But they
Okay.
don't always, correspond with the ID that Rails has. So like this in Rails is project 1, in cluster it's project, or sorry, this is project 1 in cluster, and project 2, or project 1 in Rails, project 2 in Gitaly cluster. So one issue that we see is that should the Praefect database be lost, there's no convenient way to recreate the association between the path that Rails has and the path that the cluster had. And so there's just no, unless you're backing up your database, which I don't think we really advise in the docs, there's just no way to reestablish that. You can kind of fake it if you can go through the logs for any project that was creating or getting traffic, you could at least look at recent logs and say, okay, I can translate between those two because that'll have both. But if it's like an idle project, then you're probably not going to be able to easily do it. There is one thing you can try. If we go into, oops, looking at config. Actually, this one doesn't have it. Okay, well, there we go.
Yeah,
So
we actually
sometimes,
removed that.
yeah,
Removed that.
yeah. For a long time, there used to be a GitLab section in this config, in the Git config, that would list the project name, so you could relate it back that way. I think we added that in like version 10, GitLab 10. But that's going away now. So you can't rely on that either. Okay, Sean asks, so some customers using Gitaly independent of GitLab, Hugging Face, I think is certainly the most prominent. There might be others that are doing it that I'm not aware of. So this isn't something that we officially support in terms of like, support team's not going to help them. There's most of the logic in Gitaly is pretty agnostic. There is some stuff that is GitLab specific, like authorizations, I think, are hard coded to go to internal allowed, for example. We do have documentation, if I can remember. I think it's, this. So let's throw this link in the doc.
Yeah, and for the documentation for RPCs, it's there is good amount that's missing, and that's something that we're working to address.
Yeah, this is all just automatically generated from the comments on our protobuf definitions. So it may or may not be entirely useful understanding how it works, but that it is something that's out there. And this is generated automatically if it's part of the CI pipeline, so it'll be up to date.
Yeah, so we do treat Gitaly as a product, but it's an internal product that we don't currently market externally. Hugging Face is an exception. They know what they are doing. They are super technical. They understand exactly how Git and GitLab and Gitaly works. They just want to use their own front end. So they are able to do this, but this is not something we would recommend at this point. However, where we want to be is to offer a clean RPC interface with all the implementation details and internal logic, some of which is currently managed in Rails to be moved to Gitaly. For example, how object pools are created and deleted is kind of a detail that doesn't belong in the client. Whereas we want to keep all the business decisions, things that need access to the main Postgres database, like customer tier or customer settings in the repository or in their projects, we want to keep that on the Rails side so that Gitaly can be agnostic and just be told what it needs to do.
Makes sense. Thank you, William and Andres. Very, very interesting that we are even thinking about having it as a separate component.
It may never be marketed outside. This is a product decision, but it does help us to be more independent and develop the overall of GitLab with less friction if we have a clean interface between components.
Of course. Thank you.
And to briefly mention from the product perspective, this is also really important because we've formed some very strategic partnerships through this sort of opportunity. We get a lot of contributions back from external people who are, interested in Gitaly. Hugging Face is a great example, but there are others as well that we've seen over the time where we've gotten contributions from other, teams sort of looking at it, and it gives us another perspective from a product perspective, and it does ensure that we are continuing to develop Gitaly in the most independent way, which is part of the reason why we are, as the direction page shows, trying to put the business logic into the Rails side of things to make Gitaly somewhat agnostic to who is calling it. So yeah, it's been an overall win for us, but as Andres said, we're not actively marketing it or pushing it as an independent product just yet, though that may be something we look at doing in the future.
Right. Thanks, everyone. So next question from Clement. Interested in the cost of service. What are the most costly operations? So I know on .com, using fast storage, SSD storage has been the largest cost component of Gitaly by far. It really depends on the instance, though. So .com is getting lots and lots of repositories. In a business, like a self-managed instance, you might not see as many. You might see like a single mono repository, which will still be large, but not on the scale of hundreds of terabytes that you see on .com for the vast number of repositories there. So typically storage is a big expense just because for reliable and performant service, you need to have fast storage. And then depending on the size of the repository, you may also see significant expenses in terms of compute. So if you have a truly vast repository, let's say 20 gigs, Git can easily use 10 or 20 gigs per operation sometimes, depending what it is. So if you're running multiple operations at once, and you only got 10 gigs of RAM on that box, you're going to run out real fast, right? So you're going to have a really large host in that case just to serve a repository of that size. But more typically, storage is the larger cost. Yeah, Gitaly cluster, I would say that you'd expect to spec that are the same as a standalone Gitaly node because, internally, we're treating that as a single node to the world, right? So I don't think you'd want to skimp because you're still running the same operations on a given node, just maybe fewer of them. And any of them could become the primary at any point, right? So you can't say like, well, this one's my primary, so I'll upspec that and leave the other ones a little bit wimpier because we could fail over, at any moment. How to cost scale with usage? Yeah, I mean, so typically the vast majority of traffic to Gitaly is going to be CI traffic. So, a CI runner fetching or cloning. Humans are almost always like, 10 or 20% of traffic from what I've seen at least. So, getting that as efficient as possible is the number one priority. So that is why we added the pack objects cache a while back. That was also from the scalability team. That's listed down here. So basically, when a fetch comes in or a clone, Git will generate the pack file that's going to send out to the client, and then this, using the Gitaly hooks binary, will then write that pack to disk. So if an identical request comes in, we don't need to go to Git to recompute that. So we save all the CPU power that would have been used to create another pack file. We can just copy the bytes from disk, serve it out to the client. So that saves us a lot of CPU time, but it does add additional pressure onto the storage because now we're writing all these packs that are coming in to disk, which typically they would just be a memory and stream back out to the client. So it's usually a win. Usually you're more CPU bound than storage bound if you have a whole lot of clones coming in at once. But it depends on the instance and the traffic pattern. So something to look into in general, but maybe not always a win. Okay. I think that covers that. Terry asks, any epics or issues related to sync operations required for Gitaly cluster replication? Yeah, so I mentioned this in passing earlier. We are moving Gitaly in the long run to a new architecture, which will remove the need for Praefect. So that's going to be on each Gitaly node, we're going to have a write-ahead log, basically, like what Postgres uses or other databases, where a change comes in, we save its changes to disk, and then we apply them one after the other, serialize them, and replicate the changes out to any other nodes that also happen to have this given repository. And then the client will be, in Gitaly will be routing clients without Praefect. It's been a while since I looked at the blueprint for this. I don't remember the details of how that's going to work. I think there's going to be a routing table that Gitaly will serve to clients, and then some clients will know where they can go, and we'll have to be able to retry to a different Gitaly server if that Gitaly node goes away. So there's going to be a lot more complexity in how Gitaly talks to clients when this is done. Right now it's basically Rails has an address, it goes to the address. If there's a problem, we return an error. That's it. There's no retry logic. That's that. So the client will have to do a lot more work whenever that comes around, but that's still a ways out. Okay, so that basically dodged the question. Sorry, Terry. But yeah, so we're not putting a ton of more effort into Praefect. We're still polishing it up. But so like I mentioned, like other RPCs that previously forced a replication job, we've got that down to 3, I think, at this point or something. But we're not.
Yeah, I was just being nosy. I've seen that issue that was or epic that was linked. Thank you. I didn't get a chance to read through it all the way, but we are working on a Zoox replication strategy. So I was just curious as for at least it's good, not great to hear the problems that you're encountering, but at least something to think about when we're looking at how the replication is going to work on the Zoox side.
Yeah, I'd be very interested to see what your team arrives at. Okay, I think we're at time. That's all the questions in the doc. I'm happy to hang around for another couple minutes if anyone has anything else. Otherwise, we can call it.
Cool. So thank you so much, Will, for that session. Hope that was helpful to people. So just wanted to announce that in 2 weeks, we'll be doing our next session, and the topic will be diving into Git internals, diving into Git, how Git internals help debug Gitaly issues. So that one should be really interesting. You can take a look at that issue that's linked there for upcoming sessions. By the way, I haven't set up the calendar event yet, so I'll do that shortly and send it out on Slack. But that is it. Thank you everyone for joining. Have a good day. Bye-bye.
Thanks, everyone.
Thank you, everyone. Thanks, Will.